filming. There's water coming out of the egg.
Why is the egg peeing? Logan. Logan.
I don't know. That's awesome.
That is. It's an awesome mess you're making. Yeah.
It exploded.
Hey, it's gonna spill.
It's so watery.
Huh. Why, Logan?
Because of osmosis.
Who's that?
It's the guy. No, it's because of osmosis, because of the water that rushed into the egg, and it just rushed out. But look at what vinegar does to eggs. Turns them all skin-like, like a balloon. It's balloon. They're also quite waterproof.
I think you did a good job not making a mess. Well.
Okay, so I did an experiment to see if osmosis with a potato would change its mass. So the salt potato was in a saltwater solution, and as you can see, it's all flimsy because it has lost most of its water. Not most of it, but some of it. And it has also turned kind of brown. This was my control, so it kind of stayed the same. This was my fresh water that I put in a glass of fresh water, 200 milliliters. And it is pretty much the same, except because there is a bigger concentration of water outside of it. Most of the water went into the potato, and that changed the mass, and it gained like 3 grams. And so, salt, control, water. Osmosis. Here we are blowing up gingerbread houses.
Yeah, but why?
There's the old one. Why are we doing this?
To observe the results of the explosion on the structure so that we can prevent such occurrences from happening again.
Louder?
No. You tell me.
We are studying on how explosions break all parts of the gingerbread house and not just the parts that are covered with frosting. Like our little front door split in two. Just like that.
So what do you anticipate happening to this one?
Well, this one we're just getting a bigger hole to drop our firecracker into with this one. And so, yeah, well, here we go.
So you don't anticipate anything happening here?
Just a bigger hole like what happened in the last one, and then we're gonna drop another one in.
Well, what happens if it drops in?
What?
What happens if it drops in?
The shockwave doesn't just go out; it goes everywhere inside the gingerbread house, so the pressure builds.
Okay, so the pressure will just cause it to explode outwards and fracture it randomly? Is that what you're thinking? That's a yes behind the camera?
Yes. This is worth it to clean it up.
It's not much of a cleanup.
Yeah. Well, that was interesting.
So what happened?
There went our gingerbread house.
So what happened?
We had it in the tops and it didn't go all the way in, so it just blew the top off, which is awesome.
So there's the excavation hole.
The hole didn't get that much bigger.
Oh, it did.
In the last one, it got a lot bigger.
I think it dropped pretty far in there enough to...
Yeah, you can see.
Are you still videotaping?
Yeah.
Good.
That was cool.
That was fast.
Wow.
It worked?
That was cool. I thought that you like dropped it or something.
Well, I got scared. You know, did you video that?
Yeah.
I didn't get scared. I was concerned that my presence in the area around the can would cause, you don't have to film it, would cause an upset in the equilibrium. So I backed away quickly. That's what it's called. Hey, we could do it again. And again and again and again. So that's imploding.
Cool.
Back to math.
Say goodbye.
Bye.
Bye. Thank you.
Do it slowly. Dude, what are you doing? Explain it.
How do I explain it?
Well, what's happened when?
This now has, I don't know, maybe a negative charge.
Why?
Do you think that this has a negative charge too because it's going away from the balloon?
It's repelling it.
You can hear it click. Let's see if it'll still work like it did yesterday.
Do the balloon, or do this. Hurry. Hurry! Go slowly.
There's a lot of geese.